Hi everybody, my name is Shariar and I'm your host today for this webinar. So today's webinar is going to be more focused on building data pipelines for data warehouse, and then we'll be seeing that how no-code tools help in building ETL and ELT pipelines in your data ecosystems. But before we dive into the webinar, I'd like to thank everybody for joining us today, our guests and the audience for giving us this opportunity to discuss around this topic. All right, so let's start with the agenda. So this is going to be a very technical discussion, and we'll be discussing the role of ETL and ELT in data warehousing, mainly the importance, the challenges faced in this journey. Then we'll also be discussing the challenges and some tips from everybody, everybody in this meeting around how people can improve their um, data pipeline development. And then we'll be having a look at the automation side of the data pipelines, and then there's a brief demo which I'll be presenting for Data Warehouse Builder. If anyone has any questions from the audience, feel free to paste it in the chat window, and we'll be answering it towards the end of the demo. All right. So let's start with the introductions first. We have Coin, Vincent, and Jay here. So let's start with Coin. Coin, can you give the audience a short introduction about yourself?
Yeah, all right. Thank you. My name is Koen. I'm from Belgium. I have been a consultant in business intelligence and data for 14 years now. I've almost always worked with the Microsoft Data Platform, lots of ETL, but also full stack development. But in the last years, I've also done some Snowflake and Redshift and dbt and stuff like that.
All right. Thank you, Koen. Right. Vincent. Hello.
Hi, I'm Vincent. I'm a data architect and been working mainly in the financial services, building data platforms for banks and asset management, insurance. Main technology maybe Databricks, Snowflakes, and SQL. And that's me.
All right. Nice meeting you, Vincent. Hello, Jay.
Hello, everyone. This is Jay, and I have been in the field of data for over 2 decades now. Been part of a lot of implementations for data pipelines, data integration solutions, data warehousing solutions, the whole enchilada. And I worked with our customers in different verticals, ranging from financial services to healthcare to energy, utility, to name a few. I mostly work from the perspective of our product and use this product to create a solution for our customers. So that's what my role has been. And also, of course, I lead the development and the product vision at Astera. And we have been developing data integration products for over 13 years now. And we have a full data stack, and my colleague Shariar will be presenting that towards the end. And I am participating purely as an expert of our product, and of course, someone who has a deep background in the field of data integration and overall data management.
All right, thank you, Jay. And I'll introduce myself as well. So I'm a data warehouse engineer at Astera Software, and right now I'm also working as the associate product manager at Astera Software for data warehouses. So Jay and I, and some other engineers as well, we are constantly working on improving our product, which I'll be demonstrating towards the end, for optimizing data warehouse automation and development processes. So I'm experienced in dimensional modeling and the data vault modeling as well, and I've worked with, of course, with people from different organizations in different industries. All right. Okay. So let's talk about the role of ETL and ELT in data warehousing first. Um, Mainly, ETL and ELT are two different types of building data pipelines, and there are tons of questions around, whether we should go with ETL or ELT. We'll be answering that as well. But before that, let's discuss some common challenges when starting to build these pipelines. What are some challenges faced by the engineers, of course? So let's start with Coin. Coin, can you outline? Can you highlight some key challenges that you might have faced in the past when building
So the key
these
challenges of
pipelines?
ELT, ETL, or just data pipelines in general is that it takes a very long time to create them, to develop them. If you look up Gartner or whatever, you'll see some numbers like ETL in a data warehouse project, like 70, 80% of all the development time. So it's a lot of back-end work that needs to be done. And you need to do it before it can show actual results. You cannot have a report or a dashboard or something in Power BI or Tableau or anything else without you have doing some ETL, or otherwise you have like some garbage data that is not modeled at all. So it takes a lot of time to develop something, and I think that's where automation can play a role. As you mentioned in your slide, you can reduce data processing time and development time with 80%. So that's one challenge. It just takes a long time to develop ETL. Why? It can be anything. It can be requirements, can be complex business logic, can be data quality issues. Sometimes just the business that doesn't really know what they want, they say, I want a report that does this. But when we look at it, say, okay, we're going to maybe create a dimensional model. And a dimensional model can most of the time do much more than just that single report. So we need to ask additional questions like, okay, how do you want the data? What do we need to bring in? What is the logic? And then, of course, you have like, oh, we need to have sales revenue in a report. And then you ask 5 persons in the company, what is sales revenue? And I bet you get 5 different answers. So those are all common problems when doing ELT or data warehouse work.
Right. So in short, as a summary, long development time, not scope not properly defined, requirements not properly defined by the business users, and of course the maintenance time spent into ETL pipelines. Thank you. All right. What about Vincent? So you have worked in the financial industry for multiple years. What's your opinion on what are the challenges you have faced when building data pipelines, specific when it comes specifically to financial industries?
The challenges is that it's tedious and it's repetitive. Like we need to create 100 ETL tasks, loading 100 source files into 100 target tables, and it's the same pattern, repeating 100 times. Like going to landing area, staging area, and then dimension or fact. Same with data lake, like raw layer and clean layer and curated layer. Or bronze, silver, gold. So it's not good for ETL developer or the data engineer because it's repetitive and it's prone to mistake and it's not good for the project cost.
Well, definitely. All right. So, Jay, would you like to also shed some light on the challenges faced and how a no-code automation tool such as Astera helps the users build their ETL pipelines in a faster way?
So I'll echo what Vincent said. The biggest challenge is the repetitive tasks. So if you're building any data warehouse of, I would say, even a medium size, the tasks that you need to perform to get the first cut out, where you can see something meaningful, it's a tedious process. You're doing something very similar again and over again and over again. And also at the end of it, once you're done, it's possible that slight change in the modeling, slight change in the way it was understood, that can basically render major portion of it, actually sometimes actually all of it, basically useless. You have to go back and start again. So this rigidity and repetitive tasks, those are the issues, in my opinion. They are at the top of my list as productivity killers and factors that increase the cost of data warehousing solutions, the development of that is. And this is something that we realized early on when we started to build out data integration products and the focus on data warehousing, that is. We realized that if we can do something about that portion where the templatized work can be somehow automated. So we had seen, if going back to even 25 years ago, with the Kimball style modeling has been around, and it's been around, and the practitioners, there were no tools at the time. You're talking about mostly SQL that is used to do the entire pipeline and building the entire data warehouse. It is all SQL, hand coded. And even then, practitioners, they used to have their templates that, okay, hey, you have to do this, A, B, and C, go and repeat and check and this. So they had the checklist, they had the templates, and all the practitioners, they used to go with that. So we looked at those templates that, okay, everyone has this best practices template, and everyone goes through those, and they are doing something that is very similar in nature, but error prone. Can we do something about it? That is a track we took. And what we did that we looked at building pipelines and loading into, for example, we are dealing with a star schema. Now, let's say that we already have a star schema and we are loading into all the dimensions. Now, loading into dimensions using slowly changing dimensions, type 1, type 2, type 3, 6, and so on and so forth. So these are difficult. These are not easy with, even if you are an expert, to write the code for that, the update statements, insert statements, and all that. Those are difficult. And imagine that doing it for, let's say, dozens of these dimensions, and every time something changes, you have to go and make those changes. So it is not easy. So what we did that, we took the approach of data modeling or the data models as a centerpiece of design. Use that and use the data model as something that that is going to have all the information about how you want to see your data warehouse. So kind of go in there, spend some time, configure it. So for example, if you have a star schema, go to the fact and talk about and basically configure it in such a way that the model has all the information about how the fact is, how it is connected to the dimensions, each of the dimensions. How are you dealing with the SCDs? Are you dealing with SCDs or not? If you are, what is the business key? What is surrogate key, and so on and so forth. So as long as you can create a very rich data model, that information can be used to automatically generate the pipelines. The ETL can be automatically generated. So this is the direction we took, and our entire solution is based on that. Of course, we do a lot more, but our promise is that once you are able to build a solid data model, you have done proper enrichment of the data model, then we are able to do the automation to a large extent. You don't need to go and build all these pipelines, the data flows again and over again. We will do most of it for you. So that is what our promise is. That is the direction we took.
Definitely. That's very insightful, Jay. All right. So, core fee tool, of course, that's going to help a lot. That's by templatizing the repetitive stuff, as Vincent and Jay and Cohen all three mentioned, reducing these scripts, the long maintenance type put in to those maintaining those pipelines, and the flexibility of adapting to changing requirements. So with that, actually, let's discuss the step two. The basically, once you are like have you decided you have to build a data warehouse, the first step is to gather the requirements, as Cohen also mentioned, gather requirements from the business users, that what they are actually looking for in a data warehouse, what insights they are looking forward to. So but I feel like if the business requirements are clear, if the requirements of building a data warehouse is clear, then almost 80% of your work is done. Organizations fail to develop a data warehouse in many cases, and that's mostly because of frequently changing requirements. The requirements are they're just changing. Today we are discussing this, and tomorrow something else. So the requirements are very rapidly changing. The scope of the project is not properly defined at the start, which leads to the failure of the data warehouse project itself. So I would like to also know about uh, some of the key challenges when gathering requirements from the business users or the stakeholders of the data warehouse. What are the challenges you guys usually face? So let's start with Vincent.
The challenges when getting requirements. Usually the requirements is, accurate, complete, timely. The data in the warehouse should be accurate, should be complete, and that's in reality it's very difficult to achieve.
Mm-hmm.
Because sometimes the ETL pipeline is not working, because sometimes there is a data quality issues,
Mm-hmm.
and things like that. And then second set of requirements is usually about support, production support, like logging, like they need to be alerted when there is a failure, and reporting about the quality of the data. So that's usually the requirements of the ETL pipelines or data pipelines.
All right. So basically, the requirements around how fast the data should be refreshed, should be real time or not, and who is going to provide support on the data pipelines. That's a challenge in your opinion. All right. So Cohen, can you also shed some light on the challenges which you face when gathering the initial requirements for a data warehouse?
Yeah, mostly the same stuff that Vincent said, but also when you ask, hey, how much data do you need and how fast do you need? The answer is usually like, we need all of the data as fast as possible. And then you have to go in discussion of like, do we really need all of the data? Is like 5 years worth of data enough? Is 3 years worth of data enough? Because of if you shorten the time window, of course, the ETL is going to be faster. You also have to take into account like GDPR stuff, and like some stuff needs to be around for a long time. But other data, like very personal data, you can't keep it around for a very long time if you don't have a very good reason for it. So you need to balance those two. And then you have to think about the non-functionals as well, like how we're going to handle security, who's in charge, like is there a GDPR officer? Like I'm from Europe, so it's always GDPR, but I think like most countries, they have some sort of regulation that is very similar to GDPR. So if like who is responsible for this, and then you have to like you have someone who processes the data, someone who owns the data. You have to take care of all those roles. And then you have to talk about performance, like what is acceptable. Like if the ETL runs for 8 hours during the night, but it's done when the office goes open, it's okay, or do you want it to run more times in a day? So these are all things you need to like talk about. Okay, how often do you want to run the ETL? How fast does it need to be? How fresh does your data needs to be? And then depending on those answers, your architecture might change completely. If they say, we want to run it like every half hour, it's very different. Like if you want to run it once a day. So you have to maybe change the architecture to have like CDC involved, or maybe streaming data involved. And then it's more complex. Complex means more difficulty, means costs more money. So you need to balance, like, do you really need stream data? In 14 years I've been doing this, like, I haven't met that many use cases where streaming real-time data was absolutely vital for the BI reports. In most cases, like, maybe like every 3 hours is fine.
Right. Thank you. So you highlighted some very key points. So the first one is, again, no cap on the scope of the entire project. So there's all the data as soon as possible, as you mentioned. And the second thing you highlighted actually leads me towards the next question, which I had in my mind, about the data architecture, the data warehouse architecture. So of course it mainly depends on how fast you need the data, and and how long you need to store the data. What are your actual requirements? What are you basically looking for in a data warehouse? and a bunch of other non-functional and functional requirements that you need to assess in order to suggest the architecture an organization should go with. Two of the most common architecture types I'm seeing these days is a dimensional model type, and then the Kimball architecture mainly, and then there's data vault, which is relatively new, but it's quite famous these days, and organizations are adapting it rapidly. So let's talk about dimensional modeling first. Uh, let's start with Cohen. Cohen, can you highlight some, advantages, disadvantages, and first mainly give a brief overview of what a dimensional model is for our audience, and
Mhm.
then maybe shed some light on its, advantages, pros, cons, and everything, and in
Right.
which cases organizations should go with this type of architecture.
Right. So dimensional modeling, or star schema modeling, as it's often called, has been around for a very long time, even much longer than I've been doing. I think even longer than Jay has been doing this. So it was invented, like, I don't know, in 70s, 80s. It's been popularized by Kimball. It's not been invented by Kimball, but he wrote some books on it. They were very popular, so that's why everyone calls it the Kimball modeling technique. So basically, you have, broadly speaking, two types of tables. You have fact tables, which are very long, and they measure some sort of business process. It can be sales, can be customer returns, can be manufacturing, can be anything that can be measured or counted or something that can be stock inventory, everything that can be counted.
Right.
And then you have dimensions around the fact tables, like customer, date, product, employee. And those are more descriptive. So they're very wide table, lots of columns, typically not as much rows as a fact table, and they give more descriptive information. So everyone knows a pivot table in Excel. So everything you put on the columns and on the row headers, those are your dimensions, and the numbers inside, those come from the fact tables. That's how I usually explain it to business people. Like, this is how a dimensional model works. And the biggest advantage of dimensional modeling is it's very intuitive, right? So if you just give a dimensional modeling in Power BI or Tableau, I don't care. If you give it to business users, it's very intuitive to start working with it. And I think that's the biggest advantage, because, in my opinion, your data warehouse, your star schema, is the user interface for your data for the business people. So it needs to be clean,
Right.
have good naming conventions. Everything needs to be clear, like clear names, or not just revenue, and then four measures called revenue, but they're all different. So you need to give them good names, because they're the user interface and what people see when they clicky, drag it, drop it, as we call it, in Excel or Power BI. And dimensional modeling gives you that advantage. It's very intuitive. The downside is it's not as agile as maybe data vault, because if something changes, you need to add a column. For example, in a dimension, you can track history. Then you need to think about, okay, we add a column. What are we going to do with all those other rows that already have history? Or we're just going to put some dummy value in there. So it takes more work, right? If, for example, the grain changes, like the granularity of your table. So, for example, you were keeping track everything on a monthly basis, and then the business says, oh, actually, we want it on a daily basis. Then you just need to start over, basically, for your table. So it's not as agile, but it's very user-friendly.
Right. Thank you very much for the info on that. So dimensional model, briefly, it's a star schema, fact in the middle, and some dimensions around it, giving context to the fact. Fact usually contains transactions, events, or any measurable data, such as sales, and some dimensions around it, customers, employees, and all. Just like Cohen explained. And the advantages you highlighted is reporting, of course. It gives users the power to perform ad hoc queries on the data sets, which you cannot generally perform on your source data sets, because they are typically normalized, or they are too denormalized. That makes it hard for the users to perform ad hoc analysis and generate reports on it. And you also highlighted some disadvantages, which actually leads towards some of the advantages of data vault. So over to Vincent. Let's talk about data vault architecture. Can you briefly explain what data vault architecture is, how it's basically design, and some advantages and some disadvantages of data vault architecture.
Data vaults contains of 3 types of tables. So the first set is called hubs, which contains the primary key or the business key of the entity, like client or product or store or portfolios, security. And second type is called link. Link tables basically connects one hub with another hub, but also one hub with satellite. And that is the third type of table, satellite tables, containing all the attributes for the hub. So client attributes, product attributes, security attributes on the satellites table. And the advantage of this is flexibility, meaning you don't need to change the hub. And also it's very easy to find out a summary, like how many clients do we have and how many products do we have, and that things like that. But the disadvantage, the main disadvantage, is that it's difficult to query because we need to join lots of tables.
Right. This is a pretty famous disadvantage of data vault design. So how do you recommend to overcome this type of challenges usually?
Usually they build another layer called semantic layer, or known as business vault, on top of data vault. Business vaults joins a lot of the tables underneath on the data vault and presents the complete client data or complete security data. So with all the attributes.
Right. So business vault, like, it provides some sort of a pre-computed information stored in another layer that you can use later to query your data vault design. All right. Thank you. Perfect. Jay, so would you like to also comment on the data vault and dimensional modeling architecture types, and when the users should go with, either of them?
One versus
What?
other? Absolutely.
Yeah.
So star schema has been around for a long time, and for reporting still is undisputed choice. There is no question in my mind. If you want to create a solution that is geared towards creating a good analytics reporting structure, and you want to get that result, and of course your requirements are clear, then star schema is the choice. You go with that and you're going to see the results, meaningful results. Querying is easy, and there are many tools actually developed to automate even the design of it, development of it, loading data into it, and actually publishing it out of it. So all the different parts of the life cycle of data warehousing, you'll find automation tools that are able to do that, and it can be done pretty quickly. Now, Data Vault, of course, is designed for a different scenario altogether, and that is about addressing the rigidity in original star schemas. So star schemas were the architecture of choice, but they are rigid. Once you build it, they are built for one specific set of facts and dimensions and all that. Changes on the business side are very difficult to propagate through the entire architecture, entire design, and move it to the presentation layer or that is the report. So it was addressed. It was trying to address that rigidity, to make it more flexible, more adaptable to any changes happening. And the name itself suggests it's a data vault. So of course there are different layers you got to create information mart before you can do the reporting. So you have to go through different layers before you can create a full stack of solution that is going to be able to give you the same functionality that you will have with the star schema. Of course, it is going to be more time taking, but it is more flexible. So that's how I'll compare these two. So depending on your scenario, there is no one size fits all. If you're looking for something where you're looking at analytics is the goal and you want to go about it quickly, and you have, of course, historical data that is also very important, then star schemas are really good choice. In our experience, we still see an overwhelming majority of our customers, they still go with the star schemas, dimensional modeling. Some, of course, are working with data vaults, and we do support both. We do support modeling for star schemas and data vaults, and also automation for loading into star schemas and data vaults using our product. Definitely. I believe flexibility is the key, and the rigidity actually comes from hand coding solutions. I'm using the word umbrella term hand coding. That includes writing a lot of SQL statements. If you're dealing with Microsoft technology, writing a lot of stored procs. And that brings basically, whenever you're dealing with SQL, stored procs, or I would say any kind of code, that brings rigidity. So then you have to go and modify the code. Maintaining the code again, of course, it's well known that it has a significant cost. So what I suggest always is that go for a tool set that is not code based. That is something, it is metadata based. It is more of an abstraction layer at the top of the coding. So it may be using code internally, but you don't have to deal with the code. That brings agility. So basically, you can go to your UI. Let's say it is a drag and drop interface. You can go back to your UI, make modifications with one click. It implements all your changes quickly. So that gives you agility, and that gives you basically the whole freedom to do iterations. You can make changes, and you can see the impact of it. Then you go back and make further changes, and so on and so forth. So automation at the graphical user interface level, that's what I recommend compared to using code-based or SQL-based or any kind of coding-based tools.
Vincent, can you shed some light on what ELT and ETL is, and then in in which case the user should go with a particular technology such as ETL or ELT? What are the factors mainly which the people, their technology guys should consider when deciding
Yeah. So in the early days, we have ETL. We extract, and then there is like a VM or a compute which do the transformation in memory, and then write to the target platform, warehouse or table. These days, we have powerful platform like Snowflake or Redshift or Databricks or other Spark, and we load into that platform first, into Snowflake or into Spark, and then use the computing power of that platform to do transformation. So that's ELT. We load first and then transform. That's it.
All right, thank you. Can you also highlight the factors we should consider, because when choosing one over another?
Well, the primary factor is probably performance, and the secondary is probably skill. So
Right.
performance means that if your platform is parallel processing or parallel computing platform, then it has enormous power that we should utilize that for transformation. And second thing is the skills. So if you're to use that, say for example, you're using PySpark for this transformation, that requires skills, because you need to be able to code in Python and SQL and understand the Spark's behavior, like specific behavior.
I will also like to talk about some best practices around ETL and ELT. So let's start with you, Vincent. So there are some general best practices, such as design the pipelines, keep them simple, keep them properly named, and properly maintained in project in the separate projects. And what are some other best practices that you would recommend to the users when building ETL and ELT pipelines?
Ooh. Probably best practice is metadata driven. So rather
Mhm.
than hand coding that column, mapping that column, we define the mapping in metadata, and then the
Mhm.
pipeline is generated automatically, like what Jay has been explaining. And then DevOps is another best practice. So we package, we test, we deploy using release pipeline. It's a good DevOps practice. And then another best practice is probably push down, like I just explained, utilizing the computing power of the data engine for transformations. And then another best practice is probably defensive coding. So if your source is external, say you're reading from Bloomberg or FactSet or Sustainalytics, and these companies suddenly change the length of their data specific fields, and it will so it doesn't fit into your target. So defensive coding will trim it. And well, of course, if your source is internal, then you can ask that department to let you know before they change it. But if your source is external, you can't do anything. You just at the mercy of your data provider. And then another best practice is definitely monitoring, pipeline monitoring, real-time pipeline monitoring. Like when it fails, then production support need to know pretty much immediately or soon after. And yeah, that's it.
All right. Thank you. So let's move to Cohen. Cohen, do you have any suggestions or tips
Yeah.
for our
So
users?
Vince already has some really good best practices. I was going to say source control, which ties into his DevOps argument. Like first thing you do is like source control, put it in GitHub. I don't care which source control provider you use, just use one. I remember occasions where people's like, oh, my computer crashed and I lost the whole day of work. It's something you don't want to have. It don't want to happen to you. So always put your stuff in source control. And then if you build ETL or ELT pipelines, I think it's very important to make them modular and idempotent. So modular means you don't have one big, gigantic pipeline that does everything, and then it starts running for hours, and then halfway through it crashes. It's like, oh, too bad. You just need to start all the way from the beginning. No, you just cut it up in very small pieces. Like we ingest that table, that's one piece, and then we do something with it, and then we move from layer to layer to layer into data vault or star schema or whatever. But every little functionality should be its own separate pipeline. So if it crashes, you can only restart that pipeline. All the other ones that already have finished, you can just leave them be. Like they're already finished, you don't need to run them again. So small pipelines that do one task. And another one, idempotent, means that if it crashes, you can just restart it. So with a minimum amount of clean, either it cleans up itself, and just starts running. So if you run a dimension and it crashes halfway through because someone entered something wrong and there was a primary key violation, you should be able to just delete the primary key on the funding record, then just run it, and it should be fine. There shouldn't be any duplicate records. Timestamps are wrong because you just run it again. So you should always, it should be possible to run a pipeline over and over again, and the end result should always be the same. That's very important, I think.
All right, thank you. So I see two common practices here. The first one is DevOps and source control. They go hand in hand because they are kind of interrelated. So that's kind of recommended. So audience should take note on this one. And the other one was, of course, maintaining the pipelines themselves, monitoring and maintaining them properly. So whenever something fails, the user should be able to resume back in as soon as possible without affecting the entire ecosystem. So thank you. Do you have anything to add here, Jay?
Yeah, just one thing I would like to add to what Cohen and Vincent said is that pay attention to data quality. Data quality is your best friend when you're dealing with the data pipelines. Account for data quality from the beginning itself. Sometimes it is after the fact, and that we see that later. If you introduce data quality later in the cycle, then you're going to pay some price. try to include it as soon as you can in the pipeline. So that is one thing that we have seen that helps quite a bit. And second is exception handling and monitoring. So exception handling is basically when you're designing a pipeline, account for the scenarios where it can go wrong, because sometimes, not sometimes actually, all the times, you're going to have a live feed coming in, and these days this is how the solutions are designed. So the live data is coming in on regular basis, maybe every 5 minutes, every 10 minutes, every hour, and things can go wrong with the data. So you have to anticipate those scenarios, make sure to account for anything that can go wrong with the data, how to handle it. So exception handling in general should be paid attention to as first class criteria or an objective of your solution design.
I have one more point
Right.
that I want to make.
Mm-hmm. Yeah, sure. Go ahead.
Keep it simple. In general, just keep it simple. You're not the only one looking at the code. One day you'll be gone, and someone else has to look at the code. That's one.
Has to go.
For example, nowadays we have like modern infrastructure. We have cloud infrastructure, and like tools like Snowflake or Redshift, they can just process millions of rows effortlessly in seconds. So just loading a fact table, you can just do a truncate table, insert load. You can write that SQL in 5 minutes, and you're done. But if you want to set up a whole CDC pipeline incremental load, you can maybe shave off 2 seconds, but your development time has gone up exponentially. The complexity has gone up exponentially. And also try to debug incremental loads. Oh, there's one row missing. What went wrong? And you have to go through all your data lineage to find out where exactly that row. If you just truncate load. So keep it simple, and only if you go above a certain threshold for performance, then go back to, okay, maybe we need to redesign and do some incremental loading. But otherwise, we just say truncate load if it's possible.
All right. Thank you, Gwen. So I think we are running short on time. I also have to present the demo of the product. So Astera Data Warehouse Builder is the product which we are going to demonstrate today. Whichever things we discussed, we'll be seeing them in the demo as well, because the product is built upon the user feedback which we have received so far within all these years from our different customers from different industries. So everything that Cohen, Vincent, and Jay mentioned, that has been incorporated within the product somehow, including the integrating with your sources, flexibility of your data pipelines, and building data models, reflecting changes in your data models and your data pipelines as soon as possible, being platform agnostic, automating everything, monitoring the task, the source controlling, and the DevOps pipelines. So all of that is kind of incorporated within this product. And let's begin with the demo itself. So I'll share my screen. Let me know when you guys can see my screen. So this is the Data Warehouse Builder client. The tool is client and server based. That means you have a client where you can design your data warehouses and your pipelines, and then there's a server running behind the scenes. It can be a central server which is responsible for executing your scheduled task or your jobs. So let us start with the first part, that's moving data from your sources to your staging layer. That's the first part. So the tool has this component that's called data flows that gives you the capability to build ETL and ELT pipelines. Which one you want to build, that's on you. That's up to you. And based on the capabilities of your data providers you are using and the requirements, it will optimize the job for whichever case you are running it for. For example, if you're running for ELT mode, it will optimize it for ELT mode by converting these graphical boxes into SQL statement scripts, which will be executed on the database. So, as Jim mentioned earlier, if you're using MPP databases, you need to take advantage of its processing power. So the tool does that for you. You don't have to worry about which type of data pipeline you should be building, and the tool helps you do that. And on the left hand side, you can see there are tons of sources available. So it kind of integrates with you have tons of sources available. So all the pretty much commonly available sources, such as the databases, the CRM, such as Dynamics, maybe ERP systems as well. So All of those are built in. You just have to drag and drop a connector to the designer like this. I have on my screen right now. So I'm using only two basic connectors, a database source and a CSV file right now. But you can simply drag and drop a database table source to your designer, point to the relevant data provider, for example, maybe Azure SQL Server or Postgres, whichever your provider is, point to it, then start applying transformations. So transformations, all the regularly built-in transformation in, maybe in Python or SQL Server, in SQL scripts, all of them are found in this toolbox, and all of them are drag and drop based. That means you have to write no code. So in this case, I'm joining a database table and a CSV file together using this join transformation. And again, it's a very simple transformation. I just have to select the join type and the key, and it's going to write the code for me. It becomes very easy, a lot easier actually. And calculated fields can be added using expression builders. The filters can be used to add where clauses in your pipeline. So very easy to use these transformations. And then also there are function transformations available, such as the string transformations. If you want to concatenate strings, get digits out of strings, maybe, and tons of other functions. And the good thing about this toolbox is that this is extendable. That means if you have some transformations that are specific to your use cases, you can put them in here, and they will be completely available for you as a drag and drop based transformation. That's the cool part about it. So another cool thing about data flows is that whenever at whichever stage you are in your data flow, so I'm receiving two separate data streams, one for orders, one for customers. I'm joining them together, then I'm cleaning the data a bit, and then I'm calculating number of days in this expression box. The cool thing is that I can preview the data at every point to see how the data looks like after applying different transformations. So if I want to preview the data here, I can simply right click and preview output, and it will basically read the data and in the memory, of course, and transform it accordingly to the transformations I've applied, and will preview the output to me. And this is very helpful when building pipelines because I want to see after applying transformations that how my data looks like. I can also quickly build a quick profile of my data set that basically helps me to get the statistics of my data, such as how many nulls and what's the mean, median, mode. So I can apply data quality rules and data cleansing operations according to that. And this pipeline is platform agnostic. Doesn't matter if you are running in ETL mode or ELT mode, it will take advantage of the platform's capabilities, right? So if you're running in, let's say you are running in a pushdown mode, right? So you just have to point to your desired providers and execute the data flow. In case you want to migrate to another provider, doesn't matter. Just change the provider, and this data flow will adjust itself for that provider. That's the coolest part of it. Alright, so this was data flows, and these are mainly used to transfer data from your sources to your destinations. They are used to transfer data from the sources to staging, and from staging to the data warehouses as well. Talking about data warehouses, we have not built a data warehouse yet. So let's move towards the data model component and build a data warehouse first. This is the blank data model right now, and here you have an option to reverse engineer from an existing 3NF design, or maybe your transactional databases, or import maybe files if you have your data in file structure, maybe on cloud or on-prem. If it's, let's say, maybe in Parquet files or Excel files, you can simply import the structure from those files on premises or on cloud directly into this data model. I'll go with reverse engineering. You can select your desired data provider, and maybe Azure running on my local machine. So I'll just select that. Once you press OK, you can see all the tables present inside this database you are connected to. You can select the tables which are of course relevant to your use case, and press OK. So once you will do that, it will build you a data model that looks like this. So it will go inside the database, fetch all the metadata, including the table names, the fields inside them, the foreign key relationships, indexes, the metadata of the fields as well. Everything is reverse engineered and converted into a visual format. So for example, this relationship between these two tables, invoices and invoice lines, if I click on this relationship, it's telling me that this is a relationship between these two entities. Invoice ID is coming into invoice lines table using this relationship. And I can, of course, double click to open and see its detailed information such as the constant name in the field and whether it's a mandatory relationship or not. In some cases, I've seen there are no relationships in your sources. So if there are no relationships in your sources and you want to build foreign keys here in the data model only, so you can mark the foreign keys virtual. That will basically mean that this relationship only exists in the data model and will not be created in the database. You can also double click and go inside any of the entity to see it's entirely out. So that's all the metadata that's being fetched from my source into this data model. But this is the raw source. This is not a dimensional model yet or a data warehouse yet. I want to convert this design into a dimensional model. Now, one way would be to break some relationships and create some new relationships and convert this design into a star schema format. Make invoice and invoice lines the centerpiece, and surrounding that, some other artifacts, the customer, employee, stock item, other entities, which will give context to these two tables, invoice and invoice lines. But I don't want to do that manually, and for that we have this data warehouse automation capability. That's building a dimensional model or building a data vault model depending on your architecture. So let's begin with building a dimensional model. I'll select everything, and now I just have to select my fact tables. So let's actually unselect. Let's actually select invoices and invoice lines in my fact tables and some dimensions. If I don't know what a particular table should be, whether it should be a fact or dimension, I can use auto detect, which will use the code base as STR's code base as the knowledge owner, based on the relationships and everything, and will detect whether the selected entity should be fact or dimension. And if you want to use AI that's specifically trained on identifying facts and dimensions, you can do that as well. You can see this button AI select, which will mainly use AI to identify your dimensions and facts. Then you also have the option to put in the active raw identifiers, because when you are working with dimensions, you are maintaining historical information. So you need a field to identify the active records. You have different options enabled. You can have current record designator, version number, or effective and expiration date. Effective and expiration dates are the most common ones, so I'll just select that. And once you have configured it, just press OK. And now is the time when magic is going to happen. This design is going to be converted into a dimensional model format, and you can see the colors are already changing, and here you go. Here you have a dimensional model ready in minutes. So in the center, you have your fact table, and surrounding that, you have your dimension tables, which are giving context to your fact tables. All you now need to do is configure the slowly changing dimensions with each of the fields, each of the attributes. So and that is not automatically done. Is the reason is because you might be tracking history for some fields and you might not be tracking history for some, right? So you can change that from here. You can mark some fields at SCD1 and SCD2, SCD3, and SCD6, SCD0, or insert only. If you don't want to change it ever, just leave it as insert only. And once you're done, press OK, and just move towards the next part, that is forward engineering this design to the database. Now this is a newly created design. I can simply apply DDL script if I'm creating to a new data warehouse, or if I'm just making change to an existing data warehouse, such as adding a new entity or a new relationship or a new dimension or a new field. I can simply apply diff script, which will only forward engineer the difference between the data model and the database. This one is already configured and forward engineered, so all the SCDs are marked. I can now simply go ahead and deploy this data model on a Stellar integration server. Now the reason why we are deploying is that because the database does not know about anything about SCDs or anything about dimensions or facts. How it's going to generate the data flows. We are now going to show you how the data flows are actually automated. So let's move towards the flows for loading data into our dimensions first. So this is a database source which we saw earlier, and on the right hand side you can see a dimension loader object. Dimension loader object is under this dimension loader category, and this dimension loader object is pointing to the deployment of the data warehouse. And all I now need to do is map the attributes, irrespective of which attribute is SAD1, SAD2, SAD3, etc., or which one is the surrogate key and which one is the business key. I just have to map the source to the target and execute this data flow. Once I execute this data flow, all the logic to manage SCD2 records, SCD1 records, expiration of the records, everything is automatically handled. And if you are running it in push down mode or ELT mode, you can also see the query. You can click on the query and you can have a look at all the transformations that are being applied in the SQL script itself. And by the way, this is right now I'm pointing to SQL Server. So this script is for SQL Server. But if I was pointing to Oracle, this script will already automatically be converted into Oracle syntax. So that all of that work is automatically handled. And as you can see, that this SQL query is managing all these SCD2, SCD6, SCD1, and surrogate keys and everything. Mainly, it's automatically handling them. And it's around 200 to 260 lines of code, something. So 2 boxes and equivalent to 260 lines of code. Vincent earlier mentioned that most of the things we are doing is repetitive. We are doing the same thing over and over again. So here you can see if we are not using these boxes, these entities, and we are not using the metadata where we configured the slowly changing dimension types. If we are not using that, then we'll have to custom code the queries to manage SCDs in every query, and that's going to become hard, because some fields are SCD1, some fields are SCD2. They might be you might have to deal with them separately, differently, based on their data types. Maybe all of that you have to code yourself if you're not using these flows. Similarly, for fact table, you can do the same, but this time I'm just using a fact table loader object, which is pointing to again my dimensional model, and I'm only mapping the the dimension keys coming in from the source, the business keys. It's automatically going to perform the dimension lookup process, where it's going to fetch the active records for all the dimensions based on the transaction date you have decided, right? And on the left hand side, you will see this interesting object that's called a data model query object, and that takes advantage of the source model deployment and automatically build joins between your tables. So you don't have to create joins manually, which we saw in the first data flow. I was using a join transformation. No need of join transformation even. Just point to a root entity and it will automatically bring in all the tables wherever it can be joined, right? So I selected invoice lines as the root element, and invoice lines is automatically joined with stock item and invoices. Invoice is in turn joined with employee, and you can go down in the hierarchy, right? So if you go in customer, you can see customer has a city, and customer had 2 relationships, so you can see customer twice. So all the joins are automatically made. You just now have to make the mappings from the relevant source tables to your fact table and execute the data flow. And again, if you're running in ELT mode, you can see the script that is being generated behind the scenes. So you see, again, all the tables which I had to join together, they are joined in the query automatically. I don't have to write query. And the dimension lookup process, along with the handling of different type of raw identifiers. So some tables might be using current record designators, some might be using version numbers to identify active records. All of that is automatically handled, and all the lookups are being done automatically in this script. And yeah, it's a long query as well. So 2 boxes equivalent of this query. So that's what Astera is providing to the users. That sort of automation we are providing to the users, where they don't have to worry about the complicated querying aspect of the data flows, of the data pipelines. They just have to make the mappings. based on the business requirements, business needs, and done. We'll do the rest for you. Those are data models and data flows. Then you have workflows where you can orchestrate the entire processes to being performed in a particular order or in parallel. For example, in this case, I'm running all 4 of my dimension first. So I'm loading data into my employee, city, stock item, and customer dimension, and then I am loading data into my fact table. So basically, these are data flows. A workflow is capable of calling different data flows, different jobs, and even another workflow. So it's kind of the orchestrator, where you can also perform different tasks such as decisions, sending emails, and maybe on failure you might want to clean up something, or you might want to do a specific a specific sequence of tasks after a failure of or success. So all of that you can do from here, and you can schedule all of this to run automatically based on the frequency you decide. And the frequency can be daily, maybe hourly, continuously if it's real time, or so basically based on the frequency it will ask you some other details as well. And once configured, just hit save, and then you'll get a job monitor as well, where you can see all the scheduled jobs and the submitted jobs running, and you can see the details of any of the job by double clicking on it. If a job fails, you can resume it directly from here, which was a point which Cohen mentioned, that how you can resume the job, or if something fails, and how you can keep a track of that. So you can do all of this directly from here in this job monitor. Let's begin with the first questions first. What security measures are in place to protect sensitive data during the ETL and ELT processes? I think that was asked when we were discussing the ETL and ELT pipelines at the beginning, and that's asked by Wasim. So there are several security measures that you need to perform. Some security measures are related to the provider access itself. So for example, if you're using databases, then you might want to restrict the access to your databases by giving the rights only to the relevant people. So that's one security. And then another level of security is when you're transferring data from one place to another. As Cohen also mentioned, that you need to take care of a lot of things, GDPR, and a lot of other policies as well. You need to make sure that those policies are not violated at any point. All right, so there's another question: how is the data warehouse automation field evolving to accommodate emerging technologies like AI and machine learning? I think that's a question for Jay. Jay, would you like to shed some light on it?
The whole intersection of data management and artificial intelligence is something that is evolving still. With the advent of LLMs, it has accelerated quite a bit. Before that, also, we had seen some customers asking for how to integrate artificial intelligence in data pipelines. It was mostly in the context of dynamic ETLs, that you build an ETL and it is for a scenario. How do we respond to the changes that are happening on the source itself? Or can it automatically figure out what kind of pipeline can it build? So those questions have been asked, and the solution was mostly to train models using your pipelines and your data and all that, very customized solutions. But the tool sets in this area were not really geared towards integrating AI directly. But with the LLMs, that is changing significantly. We see that there is almost a push among all the vendors to integrate AI to help automate different parts of the design, implementation, maintenance, all of that. We have also used artificial intelligence using LLMs to give user some functionality where user has to kind of go through it and decide. So for example, we are building a data model. So we can basically describe this is the model you want to build from transactional model and try to convert that to a dimensional model. So AI is able to do the first cut for you. Maybe it is only 80% right, but hey, it saves a lot of time. Then you go ahead and make the changes to make it 100%. So those things are happening already. In our product also, we have added quite a few AI-based features to enhance the usability. And second part of AI, of course, is the data science. Data science, of course, the data scientists, they have been always working with the data warehousing teams in organizations. They still work with that. And what we are trying to do is give a space for data scientists inside this pipeline. Somehow they have a direct connection, if that makes sense, to the data pipelines and have their workbench actually coming within the workbench of building ETLs. So let's say that you're going to go with a lake house architecture. You have data in the lake and you want to give access to your data science team to do experiments on the data that is in the lake. You should be able to do that using the same data tool set that you have for your ETL and other data management activities. So that is another area where we see that kind of artificial intelligence-based modeling and using that. And whole area is also kind of coming within the folds of data management, at least having a much larger intersection than it used to be.
All right, thank you, Jay. Wonderful, wonderful. So I hope that answered your question, Wasim. And okay, moving next to another question from Yusuf. What will be the first 5 disadvantages if you were to mention the disadvantages of the ELT method? So Yusuf wants to know about the disadvantages, 5 disadvantages more specifically for the ELT method. So I think one of our guests can answer that. Cohen, what about you? Can you answer this question?
I'm not sure if I'm going to make it to 5, but the first thing that comes to mind is skill. Like ETL, when I started out as BI consultant, it was I did integration services and like Bento and other tools. It's all clicky, draggy, droppy. It's all visual. You don't need to know that much technical skills. But ELT is primarily code based. So you write a lot of code. You let the database engine handle it. So you write either a lot of SQL code, which is somewhat okay because SQL is a language a lot of people in the data industry know. Or you use something like Databricks. You have to write Spark, or you use Airflow or whatever. So you need to either write Python or PySpark or Spark SQL, whatever. So lots of more languages to learn. If you're on the modern data stack, you need to integrate a lot of tools. You need to know a lot of scripting languages. You need to know a lot of tools. So I think the skills for a data engineer are much higher technical-wise than they used to be. So if you go the full ELT route, I think skills is a primary disadvantage because, I don't know, in Belgium at least, there's a shortage on data skills, on people that have good data skills. So it's hard to find people who are very good at working with data. And I can imagine it's in other countries as well. So skill might be an issue if you go the full ELT route. And I think, I'm not sure if I know any other disadvantages. I'm very pro ELT. So
so I would say, based on the disadvantages you have described, another disadvantage would be the flexibility. The maintenance part is, of course, there. Even if you get it coded, you need to maintain it in future. You might need to scale it as well. And so you have limited scalability, you limited flexibility, and all of that. But happens if you are not using a tool like Castera, right? Because you are hand coding, as Jim mentioned, and if you are hand coding, then you are limited. Your scope is limited, and your capability to adapt is limited. But if you are using a tool like I just presented, the data warehouse builder and its data flows, where you could build the data flows, and then you can select the provider of your choice, and it will automatically generate the script for that provider. If you're pointing to Databricks, it will generate Databricks script. If you're pointing to Azure SQL Server, it will generate the script for Azure SQL Server, or maybe dedicated pool. So based on whichever provider you are connected to, it generates the scripts that suits that provider. So that's a way to kind of overcome all those disadvantages. But I think 5 disadvantages are clear. Yusuf, maybe there are a little bit less than 5, but I hope you'll accept them. All right. So next is from Troy. This looks very similar to the no-code, low-code data warehouse builder application called Escape Red. Having used this tool to build a warehouse in the past, I found that when you have an agnostic tool, the SQL engine is fairly generic to be able to target as many platforms as possible. Which is discussed as how Astera can also do that. You can just point to data providers of your choice, and it will adapt to that provider. The provider agnostic tool mainly. And for situations where the default SQL is generated is not the most performant or efficient, you need to be able to tweak or extend the code produced. Is that possible, and how can you tell a stage has been modified? All right, I think that's a question for me when I was presenting the demo. So I did show a SQL script, and you cannot edit that SQL script directly, but you have the entire GUI where you can edit anything. You can add different transformations, you can add different expressions, functions, anything. So a where clause, maybe add it, sure, in the GUI using no code. And the advantages of doing that in the GUI is, again, being platform agnostic. That change will be immediately reflected in the SQL code generated. So that's certainly possible to modify that SQL, but not directly by coding, but by GUI. So the technical and non-technical users can modify the data flows equally. And then there is another question from Troy. Being metadata driven is the data lineage build, that is right click a field and having trackback analysis available, and also how rich is the documentation? Certainly, Troy, documentation for the tool, the documentation for the data warehouse which you just built is certainly available. You can generate the entire documentation in one click. The technical documentation or the business documentation, that's up to you. You can generate both, and you can also generate lineage and impact analysis. So you can see how a certain field is derived from different sources. So if you have a field that's in your data warehouse, you can see its entire lineage. And if you want to see impact of any field or any table, you can do that as well. You can right click on that field or table, and you can see the impact it's going to do in your data pipelines or your schedules or your flows. So it will just kind of look everywhere and build you a graph where you can see the entire impact of that particular field. So both of these things are you can do both of them. Okay. So there's another question from Troy. Is the orchestrator time-based and event-based? So yes, Troy, the orchestrator is time-based and event-based both. That depends on how you have scheduled it. So I did show the scheduler briefly, where you can select the frequency of your choice. So it can be continuous if you want it to be real time. It can be hourly, monthly, weekly, yearly, or it can be event based as well, such as when a file is dropped or when a submission is made to an FTP directory. Maybe a data lake, you are looking at a data lake. If something is dropped into a data lake, you can trigger a job from there. So yeah, both of these are possible. Well, this has been very interesting. I actually loved discussing these scenarios, and I loved actually all the experiences you guys shared. You guys are all the industry leaders and my seniors, of course. So thank you very much for letting me host this webinar for you all. And it was really nice to see you all again. Anything else any of you would like to add, feel free to do that before signing off.
All right, just want to say it was a pleasure to be here. I always like talking about data modeling and star schemas and other stuff. So
same here. I learned a lot today. Thank you.
Likewise.
Thank you.
Thank you. Thank you, everyone.
Right. Thank you.